6A-3, simplifying radicals with index and variables. Alright, so we labeled our parts, the index, radical, and radicand. Then it says, if the index is not written, it is an understood 2. So like we talked about the other day, okay, the last notes, there was not the little numbers out here. Okay, so if there's not a little number, then it is a 2. Then we talked about the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of square rooting something is
Solving it.
opposite of square root is yeah, we did. Did we not talk about this right here?
No. Birthday cake.
Okay, so no, this isn't birthday cake. Okay, so what I did here was 1 squared is really the same thing as 1 times 1, which is 1. 2 squared is the same thing as 2 times 2, which is 4. 3 squared is really just 3 times 3, and that gives you 9. 4 squared is 4 times 4, which is 16. Okay? So, then I do the opposite. So first I squared them and got the answers. Right? The opposite of squaring something is square rooting it. Okay? So if I square root 16, then my answer is 4, because 4 times 4 gives me 16. Okay? The square root of 9 is 3. 3 times 3 is 9. Square root of 4 is 2. 2 times 2 is 4. Okay, so notice that none of these square root symbols have a little number out here like the new notes today do, right? Okay, so when it didn't have a number on the old notes, what did we do our groups in? What did we group? How many people went on a date? 2 people went on a date, right? Because there's not a number here, and that represents, if there's not a number, then it's an understood 2. So they went on groups and dates in 2s because there wasn't a little bitty number. So today, now we have this little bitty number. So how many people are going to go on a date for example 1? 3. How many? Yes, there's going to be a third wheel. How many people are going to go on a date in example 2? 4. How many people are going to go on a date in example 5? Or 3, 5. Okay, so I have the steps written over here. We're going to just talk about the first few. It says write the prime factorization of the radicand. What does prime factorization mean? When I'm doing the prime factorization, that means the birthday cake. Yep.
Birthday cake.
So everybody write birthday cake so you know what that means when you look at your steps. Okay? So you're going to start with the birthday cake. Okay. Then it says determine the index of the radical. What's index mean?
The little number.
Little number.
Little number.
Okay, if the index is 2, then groups of 2. If the index is 3, then groups of 3, and so on. If the index is 4, then you do groups of 4. If the index is 5, groups of 5. Whatever that little bitty number is, it's going to tell you how many people are going to go on the date and fall in love. Okay? Then it says anything left uncircled. So if it doesn't have a date, where does it have to stay? At the house, right? If they don't have a date, then they have to stay at home. And then you multiply the numbers on the outside together, and then multiply the numbers on the inside together. Okay? Okay, look at example 1. My index is what? What's my little number? 3. So that means that we're going to go on groups of 3. What is my radicand? Good, 27. Okay, step 1 says, write the prime factorization of the radicand, which is their birthday cake. And what's my radicand? 27. Okay, now, we do need to talk about this. When you have perfect squares, remember we talked about perfect squares are these numbers over here. These are your perfect squares, right? You only have perfect squares if there's not an index number. Okay, that's the only way you could have a perfect square, if there's not a little number out there. Okay? Now, this doesn't have a little number out there, but 108 is not on this list, so it's not a perfect square. Okay? 289 does not have a number. It's a 2 out there, okay? It does not have a number, and it's a perfect square, so it's regular. Okay. But you cannot today because we have little numbers out there, we're not worried about perfect squares. Like example 2, 64, that's a perfect square. But because there's a 4 out here, that's not technically a perfect square because there's a little number out there. Okay, it's only squares. What's square mean? Multiply by 2, right? Okay, perfect squares, there's when you're multiplying by 2. Well, now we're doing groups of 4. Okay, so that wouldn't work. All right, okay, example 1. We're not worried about perfect squares because it has a little number out there. So what's my first step that you told me I'm doing? The birthday cake. With what number? 27. So everybody put 27 where? On the bottom. And draw your division box. Okay, when I'm dividing, what are you doing right now? Because that's not what I want you to do. You need to take notes. Okay, when I'm dividing, what do I start with?
2.
Divided by 2. The first prime number. Does that work? No. So then I move to what? 3. Does that work?
Yeah.
Yes. So 3 on the outside, the answer on top. Can 9 be divided by 3?
Yes.
Yes. And the answer on top, which is 3. Can 3 be divided by 3?
Yes.
Yes. And I get my birthday candle on top. Okay. So, because this is not regular date, groups of 2, it's not a regular date, and I know I have to have a house in my answer, okay? I want you to go ahead and draw your house now. Okay, go ahead and draw your house. Draw it big, like I did. Draw a big one. Okay, and we're going to put all of these numbers that we just got, all those numbers that we just got under the house. Okay, so 3 times 3 times 3 under the house. Okay, so that 3 times 3 times 3 is 27 broken down. So the 3's represent the 27 broken down. Now I've got the x to the 5's. Okay. 2 squared is really what?
4.
No, it's really just 2 times 2, right? 2 cubed is really what? 3 times 3 times, 2 times 2 times 2, 3 times. 2 to the 4th is really 2 times 2 times 2 times 2. 2 to the 20th would be
2 times 2 times 2.
20 times. 2 times 2, 20 times. And pay attention. Okay? Does everybody understand? So, when I have x to the 5th right here, so the 3's represent 27 because we broke that down. Then I've got x to the 5th. So how many x's do I really have? X times x times x times x 5 times. So we do that. X times x times x times x times x. How many y's do I have? 3. Y times y times y. Okay, so I'm just going to write it underneath because there's really not enough space. All of that's under the same house. If there was enough room, then I would have just kept it all in one line, but there's not. Okay, now we got to figure out who's going on a date and how many people are going on a date. What's my little number? 3. So 3 tells me how many are going on a date. So they have to be in groups of 3. Okay, please stop. Thank you. All right, here we go. How many 3's do I have? 3. All right, so the 3's, I know it's a little weird, but they're all going to go on a date. They're all going to fall in love, and they're all going to become 1 3 outside the house. Okay? So I put a 3 here outside the house. Okay, I'm still looking for groups of what? Groups of 3. Okay, so then I'm going to count 3 x's. 1, 2, 3. And that's going to be a group. Those 3 x's are going to go on a date. They're all going to fall in love, and they're all going to become one of them out there. Okay, do I have enough x's to make another group? No. Okay, so leave those there for a second. What about y's? Do I have 3 y's? Yes. Y's are going to go on a date. They're all going to fall in love. They're all going to leave the house, and they're all going to become just 1 y. Do I have anybody who's still single? Yup. Okay. I still have these x's that are still single. Right? The ratio. They didn't have a group. There wasn't enough x's to make another group. So I got to have a house. How do I simplify the x's?
1.
X.
2x.
Okay, look right here. 2 squared is really 2 times 2. So if I have x times x, what is that really? X squared, right? If I had x cubed, that would be
3.
x times x times x. Okay, so right here, how many x's do I have?
2.
2. So that would be x squared. And that's my answer. That is weird. Okay. All right. Example 2. Example 2. Okay. What's my index? What's my little number? 4. So they're going to be in groups of what? 4. What's my radicand? 64. What's my first step? Birthday cake. So everybody draw your 64 at the bottom. And we start with what number? 64 divided by 2. Does that work? Yep. And I get 32. Start with me. Then I do 32 divided by 2. 16. 16 divided by 2. Divided by 2. Good. 8 divided by 2. Good. 4 divided by 2. 2 divided by 2. I got my candle. When you get your 1 on top of your candle, you're done. Okay. Draw your massive house. Got a really big house over there. Okay, how many 2s are you going to have in the house?
6.
6 2s to start. 1, 2, 3, 4, 5, 6. How many x's?
8.
8 x's. How many y's?
2.
Okay. Okay, I'm looking for groups of?
4.
Groups of 4, because that's my little number. Okay, so I'm going to start with 2s. 1, 2, 3, 4. There's a group of 4 of 2s. Okay, I know it's weird, but they're all going to go on a date. They're all going to fall in love. It's a double date, but they all end up falling in love and become what? 1, 2.
Weird.
I know, I told you it's weird. I know, I told you it's weird. Okay, now, there's how many 2s left?
2.
2. Do I have enough to make a group of 4?
No.
No. So then I move to the x's. 1, 2, 3, 4 x's. All the x's are going to go on a date. They're all going to fall in love and become 1x. Now, I've got another group of x's. They're all going to go on the date. They're all going to fall in love and become another x out there.
Can we simplify it to x squared?
Okay, do I have enough y's to make a group?
No.
No. Okay. So here's my house. All my singles are going to go in there. How am I going to rewrite the 2s? 2 squared. How am I going to rewrite the y's? Y squared, because I have 2 of each. Now, look on the outside. Can I simplify this?
X.
How am I going to write x times x?
X squared.
X squared. Okay, so this is what it is. 2 times x squared, because I simplified them. Square root 2 squared times y squared. Yes, we do. Oh, we're doing it after lunch. Okay. I thought you meant to finish this. Okay, example 3. What's my index?
5.
5. What's my radicand? 32. What do I start with? Birthday cake. Okay, here we go. 32 on bottom. Division box. Okay, start with what? 2. 32 divided by 2 is
6, 9.
good. It works. 16 divided by 2. 8 divided by 2. 4 divided by 2. 2 divided by 2.
1.
My candle. When I get my candle on top, I know that I'm done.
Divided by 2.
Okay, now what?
The house big.
Massive house for all these 2's and x's and y's. Okay. All these 2's right here are going to go under the house. And then we'll group them. So I have 1, 2, 3, 4, 5 2's. How many y's? Or sorry, x's? 5. And how many y's?
5.
5. Okay, and what are we looking for? Groups of? 5. Okay, how many 2's do I have?
5.
Okay, so I've got a group of 5 for 2's. They're all going to go on a date. They're all going to fall in love, leave the house, and become just 1, 2.
We're gonna live on the street since they don't have a house anymore.
I guess so. They're just on their date. Okay, then I've got a group of x's that are in 5's. 1, 2, 3, 4, 5. All the x's are going to go on a date, leave the house, and become just an x. Yep. How many y's do I have? 1, 2, 3, 4, 5. They're all going to go on a date, fall in love, leave the house, and become a y. Do I have any singles?
No.
Do I have a house?
Yes.
No. Do I have any singles that need to stay home?
No.
No. So if I don't have any singles that need to stay home, then that's my answer.
Nice.
Okay, any questions?
That
That was actually pretty simple.
Was it?